Hello everyone, hello my dear students, welcome back. Here we go in the second term. We will study the hydrostatics, which means the attitude or the behavior of the fluids in the static form while they are stationary. Chapter 3, according to the classification of the school book, but it is the fourth chapter to study. Of course, in the first term, we had studied chapter 1, chapter 2, and chapter 4. This term, we're going to study chapter 3 and chapter 5. Chapter 3 is discussing the topic of the hydrostatics. First of all, I'd like to define the word fluids. What do I mean by this word? Any material which can flow. Any material which can flow can be a fluid. The types of fluids are the liquids and the gases. The liquids are incompressible. This means that there is no air bubbles or there is no sufficient intermolecular spaces between the atoms and each other to be compressed together. While gases are compressible, for example, as the body spray you are using, although it is a liquid inside the bottle, but when you spray it out, it turns into a gas. This means that the gas particles or the gas molecules were compressed. What do I mean by this word? Decrease in atomic spaces and increasing in the pressure. Also decreasing in volume. Of course, the liquid cannot be compressed, or most of the ideal fluids, of course. The liquids occupying a certain volume, while gases filling entirely the tube. Of course, if you got a tank of specific gas, it will take the shape of the tank. And if you transfer this gas into a huge balloon, it will take the shape of this huge balloon or container or whatever was the shape. Let us define a new term which is called density. Density is taking this symbol, the Latin symbol called rho. It's similar to the letter P, but we can recognize the difference between the letter P and the letter rho, or the symbol rho, of course. The density, it is the relation between the mass and the volume, or in other words, it is the mass per unit volume. M over V, the unit will be mass in kilograms and volume in meter cubes. It would be kilogram per meter cube. The definition, it is the density equal the mass when the volume equals, I don't know. Let us take an example. If we substitute in this rule, M equals rho equals M over V, the mass equals 7, for example, and the volume equals 1. Therefore, the density will be equal 7. And if the mass equals 9 and volume equals 1, the density will equal 9. This means that the density equals the mass when the volume is 1. Therefore, the density, it is the mass per unit volume. The density, in other words, it describes how the arrangement of molecules and atoms in any material. For example, the density of the iron is different from that of the copper, is different from that of the aluminium, from any other material. This means that the arrangement of the molecules and atoms in any material differs from each other. Also, the concentration of the atoms and the molecules. As an example, the density of water is 1000 kilogram per meter cube. The density of oil is 800 kilogram per meter cube. The density of mercury, Hg, 13,600 kilogram per meter cube. What do we mean by these numbers? Why are we using the kilogram and not gram, knowing that the factor is time 10 power 3? And why we are using the meter cube, not the centimeter cube, knowing that the factor is time 10 power 6? Let us say it in other words. The word meter cube, it means that, for example, we are having a container of a fixed dimensions 1 meter and 1 meter and 1 meter. Therefore, the volume is length times width times height. Okay. If this box or this container is completely filled to the rim with water, it will have 1000 kilogram of water. If we replace the water with another substance or with another fluid, like the oil, the mass will be 800 kilogram for every 1 meter cube volume occupied by oil. The same for mercury, the same for iron, the same for any other material. But we are using kilogram per meter cube due to something we called in the last year the SI units, the Standard International System of Units, or as we call it in French the last year, Système International d'Unité, which is the international system of units, using the kilogram, using the meter, using the second, and those units we are using all over the time. Okay, to convert from kilogram per meter cube to gram per centimeter cube, we have to multiply the first factor divided the second one, which will result into time 10 power negative 3, or of course divided 1000. Then the density of water will be 1 gram per centimeter cube, and that of the oil will be 0.8, and that of the mercury will be 1.6 gram per centimeter cube. About the relative density, we decided to take the density of water as a reference. Therefore, the relative density, it means that we are comparing the density of the material with respect to that of water. The density of the material divided the density of water gives the relative density of the material. For example, the density of the oil, it means raw oil over raw water. 800 over 1000 equals 0.8, which is unitless, with no unit, because the unit is being simplified from the numerator and from the denominator. For example, the density of the Hg, raw Hg over raw water, okay, it would be 13.6. To know the definition between the density and the relative density. The density is the mass per unit volume, while the relative density is the ratio between the density of the material to that of water, but at the same temperature, because as the temperature rises, the density decreases. So we have to mention that it is the ratio between the density of material to that of water at the same temperature. Keep this word in mind. Okay, and the relative density, of course, is similar in number or numerically equal to that of the density measured in gram per centimeter cube. Okay, and that was all for this session, and let us move to another part for practice. Okay, let's do some practice. In your booklet, page 9, calculate the density and the relative density of kerosene if the volume of 50 gram equals so. Okay, the mass equals 50 gram. Of course, I'm using the kilogram times 10 power negative 3. And the volume 62.5 centimeter cube. Therefore, we will convert it into meter cube. And then the density equals mass over volume equals 50. And keep it as it is. There is no need for more simplifications. The calculator will do this issue for you. 800 kilogram per meter cube. And the relative density, of course, equal density kerosene over density water. 800, similar to that of the oil, over 1000 equals 0.8. If you want to read it again, please pause this video. Okay, another one. A block of rubber foam of this mass and these dimensions. Simply we can get the mass 750 times 10 power negative 3 and the volume 0.1 time 25 centimeter. Okay, 0.25 times 0.5 equals some stuff in meter cube, and use the density by substituting mass over volume, and then we can get the relative density equals the density over that of water. Okay, that was all for density. Let's do some practice and get your homework from page 9 till page 12. Okay, right? And see you in the next session to discuss the applications of density, and also we're gonna discuss the topic of pressure. Thank you all and stay safe.